So greetings folks, in this tutorial we are going to talk about how to build a groundwater vulnerability model like DRASTIC model in ArcGIS. If you are a complete beginner, don't worry, I will hold your hand till the end. So at first, to show your model in a map, you absolutely need to have a map. So if you don't have your desired location map, then head over to DRASTIC, search it, DRASTIC, then go to it. After that, free spatial data, then country level data. Here select your country, then in this section select administrative areas, then hit OK. Then they will send you a zip file. Actually, extract the zip file in the folder, then back to our ArcGIS. But I would suggest for Bangladeshi people on another source. This is rather good one. I'll leave the link in the description box. You don't have to worry about it. So what you will download is this one. It's rather good one. It has four administrative boundaries, and we need that in this map, in this study. It's okay. I'm going to remove all of this. Fine. At first, here this is the data section. Add data. To add your data, you have to click here. Now go to the folder where you have stored your data. So you can navigate to the folder by just clicking here, then go to the folder where you have stored it, then click here, then connect it, like OK. After that, again go there and that folder will be connected. Okay, fine. I'm now going to my folder. Fine, this is my country shape file, but I don't need this whole map. So to cut your own or your desired area of interest, what you need to do is inspect the attribute table. In the attribute table, where is your study area? My study area name is Fodipur. So it's pretty tough in a large data set to find out your study area. What we are going to do is click this button here, find, then write your study area name, select find, hit find. So you can see there that now Fodipur is this field, ADM2EN. Okay, if again go to attribute table, see ADM4EN, ADM2EN. In this section you will find your study area. So see my study area for it, but we are not going to select it by this way. Head over to selection, then by attributes. Find my study area is in ADM2. Double click here, then write equal. So make sure that you have provided quotation and write your study area name, FA, and again comma. Fine, and you have to put this first letter in capital letter or as the format what they provided in the attribute table. Okay, apply. See, this is my study area. It's selected. Now right click here, go to data, export it, fine, save it in your desired location. give it a name, use study area, and here shapefile. Okay, save it. Okay, yes. Now we don't need the earlier one. Well, this is our shapefile now. Okay, now I'm not going to use this one because I have edited my shapefile to save our time a little bit, but you don't have to worry about it. I will show you everything. Okay, this is my actual shapefile on which I will be working on. What you need is Excel file. It will be required for you. Like in my Excel file, it is well depth, and you can find such information from geological survey in your locality or from literature, some reports, etc. Okay, I am now going to display it in a map, in my map. So how do we do that? So at first you have to save this Excel file in one different format to use in ArcGIS. See, my Excel file is in Excel 97 2003 workbook format. See this one. Otherwise your Excel file will not work in ArcGIS. Okay, now go to file, add data, add XY data. Okay, you must have latitude and longitude, and X field is longitude, Y field is latitude. Okay, and make sure you are in WGS 1984 coordinate system. If you are not in it, then go to edit section and under geographic coordinate system, go to world and find out WGS. Okay, click OK. Okay, fine. Now we have our data points where we have stored our depth to water table. Fine, now we are going to interpolate it. So to do that, go to Windows, search, and right here you can do it by IDW method or ringing. I am going to prefer IDW. So okay, so under the spatial analyst tool, click here, find input feature, it's your Excel file. Z, this is really important, and the Z field you are going to specify which parameter you are going to interpolate. So we are going to use well depth. Fine, give it a location name, save it. Here number of points, I have 64 points. You can change it, but if you don't change it, it doesn't matter. It will not affect your result. Now processing extent, here is your study area. Okay, now raster analysis, and a masking tool, select your study area. Okay, fine. Okay, we're ready to go. Okay, successfully done. This is our interpolated map for well depth. Now we are going to, these are classes. We are going to sort our classes. Under symbology section, go to classes. How many classes you want? So to do that, go to our table for depth to water table in meter. There are different classes, 14 meter to 15 to. Okay, depending upon this table, we are going to classify our map. So here there is only one value below 14 meter and highest 28. Okay, fine. So how many classes are there? 1 2 3 4 5 4. Yes. Okay, let me write select 4, classify. Now you're going to manually classify it. Here select manual, then it's hey, what is this? It's going to be what the hell? Oh, okay, the lower bound is 13. Now you're going to write here the upper bound, upper limit. Okay, the lower limit is 13.71. Now you're going to write here the upper limit, and our upper limit is 15.2. So right here 15.2, and then it was 22.9, 30.5, 22.9, 30.5, and greater than 30.5. Okay, apply. Fine, you can change the color, go to symbology and apply it. Okay, but we don't want to see these values. We want to convert them like this format, 14 to 52. Okay, now we are going to edit it right here. So it was 13 to 15.2. It was 15.2 to 22.9, and it's 22.9 to 30.5, and it's actually greater than 30. Okay, apply it. Okay, good. Now you can export this map, but before that you have to click here. For me it's actually in default, I have set it like this, but in the case of you it will not be like this. So okay, delete it. Then you can do like make that legend and drag a scale and arrow, north arrow. After that export it, like go to file, then export map, click here and give it a name as you wish. Then here change the DPI, maybe for paper it's 600, maybe good. You can see the paper paper requirement. Okay, fine. Now our depth to water table parameter is done. Now what we are going to do is we are going to calculate like aquifer media. How can you interpolate aquifer media? For example, I have aquifer media like this, fine sand, silt. I can't interpolate them, but one way you can interpolate them is like if you assign different aquifer media, different integer values, like silt is 4, fine sand is 5, etc, etc. Then you can again interpolate them, but this way will make some error. It's not actually a good way to do, I think. But when you don't have any option, then you have to do it by this way. Now if you have boundaries like this, then you can do it without interpolation method. But how? Let's go to our attribute table of shapefile. See, here we have different union names, and I have Equifa data by unions, so it's a good opportunity for me. Now we are going to make one new column. For what? For aquifer media, because I know that this union aquifer media is fine sand, and this union is fine, it's also fine sand, it's medium sand. So I'm not going to interpolate them, but I'm going to use another way. So let's see how we can do that. So at first you have to make one field here, right here, add field, click here, give it name like you want soil, then type its text. Okay, you'll see. A table is ready for you, named soil. See, now you can write here, but normally it will not let you write. So to write here, what you have to do is, what's happening is, go to editor. If you can't find it, then right click here. After that, here select this editor. Okay, go to editor and start editing, then select your study area. Okay, fine. Now again go to the attribute table. Now you can write in your soil column. So for example, this union or location, these Aliabad locations, soil is sandy. Okay, sandy, huh? Now similarly you can assign other soil classes for other locations or unions. I'm not going to do that because I have already done this for aquifer media in this column to save our time. Okay, fine. So far so good. Now we are going to properties, and after properties go to symbology, categories, then here change it to aquifer, add all values, apply. Okay, now see, this is our aquifer media map. Now you can't use it for rating or weighting because it's a vector, so we need to convert it to raster. So to do that, okay, I'm going to my toolbox. So how can I go to my toolbox? Click here, catalog, then it will be like this, then system toolbox. Okay, after that conversion, click conversion toolbox. Okay, we are going to use to raster. Okay, where to raster, we are going to use feature to raster. Double click here, then input feature, our feature. Okay, now select feature field. It's very important. Equifa. If you want to classify soil media, then select soil. Okay, fine. Then okay, same. Fine. There it is. Close. We don't need it. Oh, fine. Now we have two layers so far. Now another thing, important issue is topography. So to download topography, you have to head over to Earth Explorer, create an account here, then here search, go to word feature, here write your location name like DHAK Dhaka. Okay, hit enter or show. Fine. Now here you have to specify your time, then datasets, go to digital elevation. After that, here is CRTM. You will see like this. At first clear digital elevation, then select SRTM and check this SRTM 1 arc second global. Then click write result, and you will have one result. Say, then download it in your local computer or machine. Okay, I have already downloaded it. Okay, fine. Now we are going to add this slope map in our ArcGIS. So this is our slope map. This is a whole tile. It's a large area, but we want it for only our study area. Oh shit. Again, study area. Okay, now what you need to do is called mask. To mask it, go to Windows again, search, write, extract by mask. Fine. Under spatial list tool, write, then your boundary. MMS. Save. Okay. So done. Let's see. Yeah. Shit. There it is. Fine, cool. So now delete it. Okay, good. We don't need it anymore. Right. Now, what are you going to do again? This, you have to convert this map into slope map. To do that, write SLOPE. Okay. Now under Spatial Analyst tool, double click here, then again go to here, input your slope map, then give it a name. Okay, Z factor. Oh, now output measurement. Here there are two things, degree and percentage. Degree is for 90-degree, we consider it as a cliff, but in drastic modeling we use percentage. Okay, I'm gonna leave this Z alone. Okay, fine, cool. There. Oh, no, it's okay. Fine. We don't need it. Okay. Now we need to classify it, but we are not going to do that now. Now our final step is actually reclassifying all of our input data parameters. So we need a total of 7 parameters, but I'm not going to do that for all parameters to save our time. I believe if you can do these 3 parameters, develop these 3 parameters, you will be able to build this model. So without further delay, let's reclassify each of them to give our rating. Search reclassify under specialist. Now one by one. At first I'm going to give the slope map. Okay, value. Here you have to put the rating, but we don't need these classes. For slope, let's see something about slope. Range 0 to 2, rating 10, 1, 2, 5. So we need 5 classes. I can classify 5, and what are there? 0, 2, 2, 6, 12, 18. 2, 6, 12, 18, and more than 18. Fine. Okay. Now new values. These are our ratings. So let's see the table. For 0 to 2, the rating is 10. So our ratings are 10, 9, 5, 3, 1. 10, 9, 5, 3, 1. Okay. 10, 9, 5, 3, and 1. Okay. Now give it a name. It's our slope map, SLOP. Slope map. Save it. And okay. We're done. We don't need this other slope map anymore, so remove it. Okay, now we are going to reclassify our Equifa media. Okay, Equifa media. So in Equifa media, first one is fine sand and silt. First one. So our first one, fine sand and silt. It's 4. So 4, 5, 6, 7. 4, 5, 6, 7. 4, 5, 6, 7. Okay, nice. Now let's change the name to Equifa. Okay, fine. Let's save it. Okay. Cool. So delete it. Now it's for again reclassify well depth for. Okay. Now again classify, you have to what was it? So at first, if you at the first moment if you classify it, then it's actually a waste of time. You have to again reclassify it. So then 1 2 3 4 4 classes, it's actually manual. Yes. So what was it? 15.2, 22.9, 30.5 and greater than 30. Okay, now rating. So depth to water table 5 3 2 1. It's 5 3 2 and 1. Okay, good. Now its depth. You have to do this thing for 7 parameters, but I'm not going to do it for 7 all of them, because if you can do for these 3, you can do for all of them. And you can also add, people also add one additional parameter. This is land use class. And if in your groundwater nitrate concentration is high, then land use pattern might be useful. But if the groundwater is reducing zone, actually very highly reducing, then you might not get high nitrate concentration. In that case, people, maybe you don't use land use class. Okay, now we got our 3 classes. You can say 7 classes, for example, hypothetically. Then what we are going to do? Now that brings us to the final stage. And now we are going to rate it. We are done rating. Now we are going to give it weight and have our final index. Then Windows, again search, write weighted sum. You don't have to use that freaking raster calculator. Then weighted sum. Okay, 1 by 1 input your all parameters. Fine. Value, you don't have to worry about value. Values are here. Ratings, we already did it. Now weight. For depth, weight is 5. Equifa, weight is what? 4. No. Equifa, it's 3. Okay. 3. Now for slope it's 1. Save it. Final index. Okay, let's see how it turns out. Oh, what's the problem? Let's see again. Okay, 5. 5 3 1. And give it name final index. Okay, save it. There you go. This is our final index. Now you don't need them anymore, but you can save them. How to save them? To save them, you can go to File, Save, or Save As. Then where you want to save, you can save them, and when you need them, you can directly open this map. Okay. Now see, this is our final index. We don't want so many classes. Now let's see, 3 and equal, not equal, quantile. Okay, apply. We're going to use applied. See, this is our final index. Now you can use validation method, like in which area how much arsenic or chromium or nitrate concentration is. So this is your final map. After that you have to insert legend like this, next, background if you want, next, and finish. That's it. Zoom to layer. Okay. Okay. So now our final map is ready. So you can play around with the index and to measure the area for each different classes. You can see my another video on it where I described it. You can find out your area without using any raster calculator. So that's it for now. I think you find this video really helpful. If you have any question, let me know in the comment section, and I would love to hear from you. And if you have any suggestion, I would love to learn from you. So I hope I will see you in another video. Thank you.